So, ladies and gentlemen, welcome to our roundtable, seabed warfare, new challenges for autonomous systems. Very honored to see you. I am Jean-Marie Dumon, Deputy Director of GICAN, the French Maritime Industry Association, built around more than 300 companies working around naval and maritime technologies for civilian and defense markets in France and with many partners, international partners. Competition and confrontation are expressed today, particularly in the seabed, a sort of new maritime frontier from shallow waters to deep blue. In this roundtable, we have the opportunity to welcome high-level military and industrial experts. They will address the technological and industrial challenges that we must anticipate and will interact with the audience in the second part of this roundtable. First, I will come directly to give the floor to the panelists. And first of all, Rear Admiral Harold Liebregs, you have an impressive and various operational background, as many positions in the Royal Netherlands Navy. Force commanding time at sea. Force. 2 submarines, 1 frigate, and 1 capital ship, amphibious ship in your Navy. And also, you were a key player for maritime operational requirements and maritime in material and sustainability policy in the staffs. And now you are the deputy commander of the Royal Netherlands Navy right now. So my question for you is around the future of the Royal Netherlands Navy. Your Navy will be substantially impacted by the add value of unmanned systems and autonomous systems, in particular for underwater missions. What is your approach for the different warfare domains now and in the future?
Well, thank you very much for the introduction. And let me start by saying thank you for the invitation to be here in this wonderful conference of the Paris Security Forum. Really delighted to be here and to discuss all these events. And there's no need in this audience to tell that the world has changed. So I won't go into that. But as a result, defense budgets are growing, and for the Netherlands that means that we are growing towards the 2% of GDP for budget, and specifically for the Navy, that means that we will be replacing the entire fleet the next coming decade, including submarines, but basically any ship you can mention, can think of, will be replaced. And given the difference in times, we cannot do that in the old-fashioned way, where we used to replace one class of ships by the other. Because if you look at the experiences from Ukraine, and I think there are at least 3 lessons to take away. First of all, I was surprised by the effectiveness of underwater unmanned surface vehicles, USVs, in sea denial operations. Second of all, it underlines the importance of numbers, mass, and dispersed operations, also in the maritime domain. And thirdly, and I think our Minister of Defense said it yesterday morning, the importance of hybrid warfare, which is warfare in itself, and especially with regards to vital infrastructure in the North Sea, specifically for the Netherlands, for energy supply and communications. So what does it mean for the Navy? And it means a lot. And I will pick one element out of our approach, and it's a very modest, new type of vessel. It's only 50 meters long. It is commercial off the shelf. They are literally already built and available, and it's low manned. Not unmanned yet, but low manned. And they are easy to purchase. We had a tender out a couple of months ago. Last month we had a decision, and the ship will be sailing with civilian crew already in May prior to the NATO summit that we are hosting in June. And the main tasking for this ship will be following Russian ships or Russian-related ships like the Shadow fleet. But soon the ship will be replaced and will be followed up by military-operated and owned similar vessels, very similar vessels. And you can do a lot of things with these kind of ships. If you put a container with air defense missiles on board of one of these ships, you can expand, you can increase your dispersed operations, and you can increase the firepower of our air defense ships. And that's just one solution that is you can think of, but we're actually purchasing it already. But you can also think of other stuff like sensors, electronic warfare suites, or maybe sonar systems. So you can materialize on concepts like multi-static operations and to have a low-cost weapon carrier. And that is very short term. I'm already talking about the end of this year to introduce stuff like that. So we need to step up. And of course, you can also use this system for the commercial vessel already with unmanned underwater vehicles to survey the sea bottom. And that's where we benefit from our project that we already have with Belgium. We are replacing our mine hunting vessels at the moment. And we are purchasing the toolbox made by EXAIL. And it is more complex than you think. If you send out a drone towards a minefield and expect a drone to launch a drone remotely, then you run into a number of issues. For example, communication. What if communication fails? How do these systems handle in rough seas, in real life? What if, how do I get the information back on board of the ship, and how do we evaluate the information back home? And there's also legal issues. You cannot fly any drone above populated area, and you cannot sail any drone very close to a seaport like Rotterdam. There's legal concerns in this respect. So how do you tackle these questions? And I think the main one is just start anywhere. I don't mind where, just buy it, start testing, start evaluating, and develop your concept along the road. We've done that with the MCM toolbox, the MCM vessels we are purchasing. But we also have a concept that is located near The Hague. It's called Sea Security, CSEC. And that's an area where we can operate with drones in real life. And it was an initiative originally from the Northern Naval Shipbuilding Corporation, but we're now opening it up to NATO and European countries, where you can test together with industry and nations equipment in real life circumstances. And for example, we will be having a challenge week in May, also just before the NATO summit. And one of the main highlights there will be 20 industries conducting the challenges. And our focus will also be on data, handling the data, data science and data fusion. Because I think the data is one of the key elements in working with drones. So we're opening it up, and for now, I have an open invitation to you all to join in if you see fit. Thank you.
Thank you, Admiral. So we come back on some question after with you. Now I give the floor to Admiral Pannetier, Nicolas Pannetier, just to present quickly your operational and managerial background. You have an operational career, notably as a commanding officer of the well-known Navy SEALs French commando Hubert, and also surface fleet's experience as a commanding officer of a frigate overseas, and also many managerial responsibilities for special operation general staff in France, and also the Navy headquarters in Paris, and now you are the Deputy Surface Fleet Commander in charge of the mastery of the seabed. I think it's the real traduction in English, but you will, yes, you will explain more than me. So, from the French Navy perspective, what is your operational seabed strategy, your challenges, in particular in deep seas, and what game changers are you observing? Thank you.
Many things. The first point I want to underline is on original DNA for the French Marine Nationale. The French Marine Nationale is either the French Navy and also the Regalian administration for the offshore. And this both DNA branch could explain a lot of things in our seabed strategy dedicated to the French Marine Nationale. This point is the first one to well understand our position. Like all the modern navies, the French Navy recognize the seabed as a new, yes, perhaps not more new, but a new strategic spaces that shows that it's a space of conflictuality, of course, of the economic competition, of course, of the contestation, of course, eventually or perhaps confrontation, not truth, hybrid or potentially asymmetric threats. So we are obliged to manage with the seabed control now. There is no solution. And this seabed control is directly linked to the rest of the Navy, and especially to two strictly military domains, the mine and the submarine warfare. For the mine warfare, we can remember that Ukraine and Russian forces both accusing each other of mutually of having mined the Black Sea, or it could be the Houthi menace in the Red Sea. I spoke about that because with cheap military costs, an undersea mine can pronounce a complete maritime interdiction. So to manage the seabed control is also a key part of the mine warfare. And for the submarine warfare, it's due to very modern, technological, and confidential point of view. But what I can affirm, it's observing the surface from the seabed is becoming a truly game changer for the submarine warfare. For the guys or for everybody who don't know that, it's clear to well understand that to be able to highlight all the waters and even the surface by the bottom is becoming a key point for all the navies. And for us, we have put our deterrence, our nuclear deterrence in the opacity of the underseas. So the gameplay is huge for every nuclear marine navies to be sure that we well control the seabed, to be sure that this submarine warfare is not completely changed. So for us, for the Marine Nationale, this seabed control includes, of course, deploying autonomous ROV and AUV systems. And the other point everybody has to well understand, it's the difficulty increase with the depths. to summarize, from 0 to 7 meters, human being can easily accomplish a wide range of tasks. It's easy. From 100 to 300 meters, it's a crucial zone or depths because it's directly dedicated to for securing our continental and maritime approaches. So it's important to be well equipped and well active and present in these depths. Until 1,000 meters, underwater systems become more complex. It's become to require a professional expertise, but it's yes, we can manage to 100 meters. Up to 100 meters, till 3,000 meters, the difficulty increase more. It could be explained because oil and gas are acting and present, so the technological solution exists, but it commences to be huge. And beyond 300 meters, it's another space. And the aim given to the French Navy is to reach 6,000 meters. Why 6,000 meters? It's because 87 or 88% of the seabed are above this limit of 600 meters. So it's become to be a sort of insurance to be able to act all over the world above 600 meters. But to reach this depth is a huge challenge. Today, only scientists has IFREMER, the French Institute for Research in the ocean, are able to reach that sort of depths. It's the challenge given to us. So we are ready to, with EXAIL, to work tomorrow to this huge and very impressive depths for everybody.
Thank you, Admiral. Yes, the perspective of under 6,000 meters is also an industrial challenge. And so pleasure to give the floor to Jérôme Bendell. And Jérôme, you have a huge operational and management experience from more than 30 years in the aerospace, defense, and high technology sectors. First, career in the French Ministry of Defense as program director, and after in prestigious companies like Thales or Alcatel-Lucent. And now, you are president of EXAIL Robotics and director of EXAIL Maritime Division. And I wish to ask you this question because EXAIL, your company, is an experimented one in this domain from many years, 40 years ago, of technological mastery of the deep seabed. And what are your industrial challenges and perspective you are facing now?
Thank you, Jean-Marie. You're too nice with me, with my career. I have only limited experience, and especially in naval. But at least the one I'm living now is very, very interesting and very exciting, in fact. Because EXAIL, it's a nice company. It's what we call ETI in France, a small, a mid-sized company that has been created in 2022. We are 2,000 employees and doing a 370 million euro turnover in 2024, and having a huge business in drones, to be clear, because we have a 1 billion order book to deliver in the next 4 years. So, and in 1 million euro books, you have more than 800 drones to deliver. So we are quite active in the sector, to be clear. And so I'm very happy to comment a little bit on the deep sea part of what we are doing, because we are lucky enough in France to have an industry like EXAIL that is able to master the complete depth starting at 6,000 the bottom of the sea, I will say, up to the surface, and which is a chance, which is really an opportunity. And so on the deep sea, in fact, we started very early, probably too early, as we say in France. When you are too early, you are not always right. So we started in the 90s, in the 80s, sorry, delivering a ROV going up to 6,000 meters for Ifremer, called Victor 6000, which was a very good experience for us, for sure, for Ifremer also. And we have been able to do more than 15,000 hours diving with this tool. So it has opened the way to this deep sea exploration. At that time, it was more very scientific to see what kind of mineral you can find on the bottom of the sea and things like that. For sure, things have moved a lot since then. Now we have, as explained by Admiral Pannetier, we have many new missions to cover with this kind of tools, and we have been able, and it was a need, in fact, was a request to move from the ROV, the drone with a cable, to a full autonomous capability, which is required, in fact, to cover more ground on the depths of the sea, and to be able to do more specific tasks. And so we have been able to do that recently. In fact, it's quite recent technology, which very few companies in the world are able to master, delivering the first fully autonomous AOV 6,000 meters from French company, at least, to Ifremer in 2021 or 2020, I don't know, 2021 or 2022, and that is now really used by Ifremer. And this drone has a very interesting capabilities, because it's for sure able to behave itself in the deep sea with no limited connection, no cable, very few connection, because acoustic communication is limited at this depth, but able to do some missions with an autonomous capability, able to reorganize its mission depending on what it can see, and take and do a certain number of tasks more for scientific purpose. And starting from this, coming from this very nice experience we had with Ifremer, we have been lucky enough to start a new project with the French Navy and the French Ministry of Defense, Army Ministry, which is a new 6,000 drones, deep sea drones, called A6KM for military, which will be able to which is derived from the current one we delivered to Ifremer, and will be able to do even more specific missions, and especially embarking a lot of critical payloads to do certain specific missions requested by what talk a little bit Admiral Pannetier talked a little bit about. And so this is really a dedicated tool, a tool of sovereignty, because it is a tool with no American components. It are free and really completely developed and made in France. So really, we are very proud, to be clear, to be able to go to that way, and will deliver the capability in 2027 for the Navy. And we are accompanying the Navy also now, because now for sure we don't have this tool already, but we have the one from Ifremer. We have also one other tool, which is another drone that is going up to 3,000 meters, which is used by French Navy in the so-called Calliope missions. And so we are, together with the Navy, increasing our way of dealing with this kind of mission in very deep sea, improving for sure the technology, and I will come back a little bit on the challenge, but and including also the use, how to use the drones in this kind of environment configuration. So our only competitor, the one we recognize at least, is Kongsberg, which is very well known. But we think we are doing a very interesting thing also. I won't see better, but at least different. Okay. What are the technological challenges? This was your question, Jean-Marie, sorry. So on top of what I said about being able to go and to have an autonomous behavior without connection in 600 meters, you have also to think about the future, what will be critical for these drones. For sure, you have navigation, you have autonomy capabilities, all we are doing in EXAIL, but We are also thinking about capability of interconnecting drones and having some swarm drones able to do that also in deep sea. And my colleague from Arkeocean will talk about it later, but we are also deploying some research project to connect our drones together to be able to monitor even faster the deep sea using many drones together, connected together, able to cover in a swarm way more ground in the same time. We have also, for sure, we are working a lot on the autonomy part of the drone, which is very important in that kind of environment. So, and we are developing AI capabilities for our drones to be really able to have clever, smart behavior, finding some new difficulties, some new events, some new things to do on the sea, and taking the best of the 24 or 48 hours mission on the bottom. And last but not least, these drones will bring back a lot of data, which are already there, in fact, but more and more, and this is a very critical topic to deal with this data and to have data management and tools able to deliver to do that. So we are working on that, also using AI capabilities to really increasing the efficiency of this data management. And okay, I think I talk a little too much already.
No. So I will come back to you after for other precision of your purpose. But now it's time to, dear Tamara, Brizard, to welcome you. Happy for that. You are the co-founder of Arkeocean. It is an innovative SME contributing to autonomous underwater groundbreaking solution, really, and for many sectors and needs in the world. You have personally an impressive university path in US universities around computer engineering, and in France, very different paths around Mediterranean archaeology. So you have an international profile too, because you lived in the past in the two countries I just evoked, but also in the UK, Belgium, and Australia. And my question for you is, because Jérôme is just speaking around swarms interest. So with swarms of underwater drones, you address new problems, but new solutions regarding the capacity of human beings to act underwater and trace technological and dual paths also. Is it a dream or a concrete solution for navies to imagine such resident drones colonies under the sea?
Merci Jean-Marie, and thank you very much for the very flattering introduction. So the short answer is no, it's not a dream, and it's a near reality. But there's multiple steps that need to be first concluded to get to colonies of swarms, especially at 6,000 meters, which is a very big challenge. At Arkeocean, we work on swarms of small AUVs, autonomous underwater vehicles. When I say swarms, I'm talking about hundreds and thousands of drones. I'm not talking about a couple. And when I say small, these are drones that are less than a meter, so quite small. And this is in the world in which we work. We work in the energy, environment, and defense industries. We're primarily actually in the civil world, and we only entered into the defense sector in 2020 during COVID. So there's actually a lot of activity in the civil world, which could be very interesting for our defense industry. So yes, you were telling. So where are we right now? Where are swarms, and where are we? How are we going to get to colonies of resident drones underwater? Swarms are challenging for various reasons. First, cost. We need to bring down the individual cost of a drone to be able to say that we want swarms of thousands and hundreds or however many. So that's a first hurdle that we need to address. The second hurdle is the positioning, because one of the major things in underwater is positioning. There's not much technologies that work in the ocean, especially salty water. We don't have GPS, we don't have radio. We only have really acoustics that work, and it's a big challenge the further down we go, especially providing precision data, precision. So these are the hurdles, Arkeocean, we tackled to be able to come to solutions that our clients need, especially in the energy sector. We were talking about the oil and gas. Today, they work up to 4,000, even over 4,500 meters. So these are our clients coming to us, and we had to address this all while cutting costs, which is no little challenge. So we have this experience, and we've developed key technologies that allow us to provide solutions that are inching towards and are very close towards having swarms of resident drones. Notably, our positioning system, which is the Seeker, which allows us to do docking stations underwater, because even though the positioning is one of the hurdles, energy is also a hurdle, especially if you're sending drones to great depths. It takes a lot of energy to reach these distances, also a lot to come back up. So especially we're working with small drones, so we don't have much, we don't have a big payload. At least we want to keep as much payload for sensors as we can, so batteries shouldn't take up the biggest part of the payload. So we have to be very strategic how we work on these issues. And so recharging, so we can have two solutions, or bring more energy and try to stay as long as we can underwater. But when we want resident drones and we want to stay long periods, and I'm talking about months underwater, even more, you need to have a way to recharge the drones at depth. So we work on solutions, and I'm going to show you talk about a couple projects we have ongoing and programs we have that showcase this technology. The first one I'd like to talk is one for the environment, which is completely different, but the environment is an interesting sector because there's a lot of synergy and a lot of potential collaboration between environmental needs and the defense industry, because most of what we're trying to do is collect data, which is kind of common to these two industries. We have a project called EONIOS, which is being developed with a maritime institute in Cyprus, and it's for a resident drone that recharges in a reef, an artificial reef, and is there to monitor wildlife 24/7 and to be able to be in contact with scientists 24/7 and feed data to the scientists so that they can monitor conditions, but also the evolution of wildlife in real time. It is also another aspect. It protects these reefs and is able to give warnings if any unwanted activity is heard or foreseen or seen on site. So this is a quite interesting project. This project we are delivering at the end of this year. The first pilot will be in Cyprus, and it shows, first of all, that we can make small drones that can stay for over 3 months underwater and recharge. So we can do docking stations. They stay at shallow water. So this is a first step. They won't go over 100, 300 meters. That's a first step. But it shows the technology, and it's a way of debugging and proving concepts at shallow depths. So but we're working on other projects that we're going further down. And in the oil and gas industry, we're working on swarms of thousands of drones that will be delivered. We have one project where we're delivering multiple thousands of drones within the next 2 years that will be going down to 3,000 meters. And using the same core technology in the end, the same building blocks, just that can withstand higher depths. So just to say, it is not a dream. This is not a dream. This is something that's coming. It's not something that we hear much about, but we're not the only interested parties. There's a lot of different sectors in the maritime industry that are interested in these concepts. It allows us to have a presence where human beings currently cannot be, and even less for long periods of times. So when we think about France, who has the second biggest maritime territory, and to be able to enforce our sovereignty, to enforce the fact that this is our space, we need to have the tools to be able to do so. And swarms of small drones are not coming to replace what exists. What EXAIL does and the tools they're developing are extraordinary. They're very high-end, very high-precision tools. Swarms of micro drones are here to complete what can be offered and the solutions that can be offered to our navies. But more so too, they open a new way of envisioning things that can be done, a new way of seeing how we could place technology underwater. So I think the future is bright, and no, it's now. It's now. So thank you, Jean-Marie.
Thank you, Tamara. The future is now, so we can come back to operational challenges because it's now too. And I have a second question for you, Admiral. As you explained to us, your country decides to accelerate the renewal of your navy with new generation of assets like submarines, autonomous mine warfare systems, with a common approach with the Kingdom of Belgium, as you explained to us, and also new frigates and many other tools. What are right now the capacity, skills, systemic approach challenges you are facing, in particular for seabed operations?
Yes, the main challenge, if you look at seabed, in my opinion, is not a technical one. Although I admit I'm here in the wrong, amidst the wrong people. But if you look at the challenges at the seabed, I think it's the complexity of the governance, at least for the Netherlands. And I think Admiral Faucheur and Admiral Norlin this morning had a very good discussion about this already. But I think seabed warfare requires a whole of a government approach, if not a whole of society approach. Because companies that operate vital infrastructure, critical infrastructure underwater, they need to protect and monitor the equipment themselves. That is not a state responsibility. And at the same time, we have a Coast Guard organization, and that's mainly related to safety at sea. But when the threat is evolving, and we're talking about state actors, then of course the Navy has a role. But not always, because if it's about crime, or like a renegade-like scenario at sea, which we can all imagine, just take a tanker, an LPG tanker, and run it into the port of Rotterdam, and you can have a huge disaster. In those circumstances, in our system, it's the Department of Justice that is in the lead. So the main question is, how do you organize the data, and how do you catch your indications and warnings that you can react and step up and escalate in this domain? And I think one of our solutions would be and could be is that there's some sort of a joint interagency task force where all the organizations can bring in their information as they see fit to share and allowed to share, because some information cannot be shared to anyone. If you're talking about legal information, it cannot be shared to companies. And some information by the companies that they own that cannot be shared with other companies or with any other agency related to the state. But if you put them all into the same room and see what the information do you have and see what's happening, and then you can decide what organization is in the best position to react and, if need be, escalate if you're positioned this joint interagency task force close to politics. Because I think the politics should be involved in very early in seabed warfare. So it's an organizational problem that we have to solve first, and at the same time I fully recognize that there's huge of technical challenges underwater as well. But my main focus as being the Deputy Commander of the Navy now is in the governance about data handling, data sharing.
Yes, thank you, Admiral. I try to understand what you expressed before, all in particularly Admiral Pannetier. You express, in fact, that these new seabed capacities are mandatory for your missions, but it could need specificity for perhaps around operational maintenance, skills, many things about data-centric approach, as you express, and choices also in the variety of military payloads embedded for missions, from shallow waters, in fact, to for mine warfare, for example. or to protect some maritime infrastructure to deep seas. So how French Navy is acting for that?
To highlight this question, I choose six case orientations to answer. The first one is, of course, have the capability to do and to know, to monitor, and to act on the seabed is impossible without a set of essential technologies and tools given to our country by our companies. So a part of my job is to stress our French companies to be sure that they will be able to give us, to the French Navy, to the Marine Nationale, the better tools, the cheaper tools, the more effective tools we need to act. So it's a part of my job. That's the first one. The second one is to be sure that we will be able to do the operational maintenance. And as everybody working in this huge depths, we are facing the same constraints and difficulties. So the difference is to be sure that our teams, or seamen, or petty officers are able to do the operational maintenance alone as French, as a military teams. And it's a bit more complicated than in a civilian commitments because we will have to do that perhaps far away from our bases, perhaps a long time after leaving the port. The third orientation is to be sure that the French Navy will at time to develop the good skills by the good human resources. To well understand, to go to the deep seas, the seabed warfare doesn't exist 10 years ago. It's a bit exaggerated, of course, but to be honest, we lose a lot of competence during at the beginning of the 2000s. In the 20 years ago, we lost a lot of competencies about this deep intervention. So we have to rebuild these human resources and these skills. Fourth point is perhaps the mission versatility and modularity we are asking for, or we are looking for. The military payloads and the effect we are looking for are specific, so we have to manage with our companies to be sure that the good payloads will be at the good place at the good time, and it's sometimes some specific. We can imagine that, for example, if Romer is going in the deepest sea or in the huge depths, not for the same task as us. It could be clear. For example, we ask for AUVs to be able to make a stop. In English, it's hovering, to make a pit stop just over the target. And it's a technological challenge because in normal way, an AUVs continue to proceed. And for us, it's important to be able to make a sort of hovering of the target. Another requirements, we ask to be sure that the tools will be airlift capable. And the airlifting, it's a huge challenge for the companies because all the vibration and the airlift commitments are specific. but it's important for us to be sure that we could act worldwide and perhaps tomorrow far away from France. Of course, we ask a focus of agility and autonomy. To underline this point, you have to consider that the cable launching system for a 6,000 meters ROV is about 45 tons. So we have to track these tons. We have to be the more light we can. It's important for our military mobility. 5 spans, it's of course the data-centric approach. Of course, Jérôme spoke about that, but for us, we have to overlap these requirements, of course, by sensitive and confidential data. We have to process, to capitalize, and to adding value of this huge quantity of data. And we have to make effort that to be sure that our teams will be able to exploit and to be efficient with that so huge data quantities, and it's a real challenge for us to be sure. And the last requirements, it could be to be aware and to be ready to collaborate and to strengthen partnerships, of course with other navies, of course with our companies or foreign companies, and perhaps in a bilateral relationship or in NATO framework. We have to go deeper. No, not go deeper. We have to strengthen a lot of partnerships, because we can't afford to progress alone and with no benefit of being linked to the other solution or capabilities of our partnerships and of course NATO navies. That's the C. For me, it's the C requirements of our challenge for the French Marine Nationale, and to be ready to act, to monitor, and to know what is on our seabed operational areas given to us.
Thank you, Admiral. In French, it's du pain sur la planche, many bread to cut. So, Jérôme, I come back because we are in a sort of new landscape with the duality. Many technological challenges, and operational too, of course. Understanding of these needs you have now, and prospective approaches in each company you are facing. So how do you implement really agility for industrial results now, from surface level to IDIPS solutions you may propose to the navies?
Thank you, Jean-Marie. First, I would like to mention that the challenge of Admiral Pannetier is very, very big, and we are very modest to try to support it, but for sure we will need other partners also. Anyway, on our side, to be very, very transparent, we are really leveraging the duality of our tools, our product, and markets also, for sure. So we are both positioned on the classic scientific and hydrographic or oceanographic market with agencies and other and also private sector that is using this kind of requesting this kind of capabilities. And on the other side, for sure, we are leveraging the more defense market, where we have a lot of stake for the moment, and this conference here, for sure, talked a lot about it today. But not only the duality is duality of market and technology, but also duality of clients. I mean, we are also talking for a lot to foreign customers, to export market, and that's a very strong leverage for us to be able also to offer our capability to overseas customer as well as for French, and it helps us to have enough strength. I mean, to be ready to tackle the challenge Admiral Pannetier talked about, because we have already been able to do things for other customers. And I will give you an example. We are delivering a unmanned surface vehicle called the DRIX, famous for hydrographic and oceanographic agencies around the world. And the first one has been sold in France last year, after 29 others being sold to other companies, to other customers outside France. So that means that we need to leverage this market globally, and that's one of our ability of EXAIL, and that help us to deliver the best for all the customers. When I come back on the duality, we have duality on all our drones, and not only the surface drones. The DRIX, to talk about it again, has also been used by the US Navy as a support for what we call maritime awareness capability. And probably, hopefully, will be used also by either Navy. I know that the French Navy has tried it already. So anyway, so that's a duality. The product has not been made for this purpose, but okay, it can be used for that. For our underwater drones, for sure, these drones are dual by essence, except the one we are making to kill the mine. This one is specific to kill the mine, but when you are dealing with monitoring of the sea for mine warfare, it's the same kind of sonar you have on board than the one you can use to deliver oceanographic or hydrographic bathymetry, what we call bathymetry data. So that's the point, and so we are able to cover that with the same tools, in fact, and which are adapted for scientific purpose, but also for military, for monitoring of the seabed, whatever the depths, small depths, limited depths up to 300 meters for mine warfare, and deeper if requested with specific tools. So that's really the point. One other topic I would like to talk about, and I won't be too long at that time, is one of the things we are trying to develop at EXAIL is verticality, meaning that we want really to master all our critical equipment inside our vehicles to make sure that we can deliver the best performance and the best vehicle, and also that to make sure that we are able to be, I mean, I will say independent. It could be interesting from a sovereignty purpose, but it's also interesting from an industrial purpose to be able to offer what we want to offer to the customer that request our capabilities. And especially, I can tell you that our drones are very efficient because we are manufacturing inside EXAIL the inertial reference system that is aboard the drone, and we are one of the leaders of inertial system in the world. And so that's a key asset for this kind of vehicles. If you want to autonomous navigation with no inertial, you cannot do it. On surface, it's very difficult. Under surface, it's impossible. So, first. Second, we are also delivering the underwater communication capability. I mean, acoustic capability, communication capability, and acoustic positioning of the drone, which is critical also to when you have your drone that is coming back or that you have to synchronize this position with the ship, and this is done with this kind of tools, and it's very important. This is something we are doing for sure ourselves to make sure that we are mastering that also. And last but not least, we are doing one of the key sensors of the drones, the sonar. The sonar is really critical for underwater drones, and it's more recent at EXAIL, but it's still there, and we are developing some synthetic aperture sonar, imagery sonar, to monitor the underwater environment. And we are doing that also for sonars that are going up to 6,000 feet, 2,000 meters, sorry. for sure, because we need our sonar need to be on board our vehicles, and our vehicles are doing to the depth. So that's the target, and it is done. For instance, on ULIX, the one from Ifremer is equipped with a synthetic aperture sonar built by EXAIL, delivering some very nice picture. You should ask Ifremer. It's not on me. So that's the point. We are really working on this verticality, having on board. I won't talk about the battery, but we are also doing not our energy cell, but our integrated battery for our drones to make sure we are also able to have this capability. So again, the idea is to be able to try to tackle the challenge of these two guys in uniform. On my right, we are really working to have all what we need in-house to be able to deliver the best solution, hopefully on the shelf, but it's not necessarily completely on the shelf what they are requesting. So we need to adapt, and we are doing it as best as we can. Okay.
Thank you, Jérôme, for this aspect. And I think there will be more exchanging in the future, of course, around that challenges. So Tamara, you keep, in fact, your innovative startup spirit in your company, and you have many dual experiences, as you explained to us. But really, how to revolutionize really the protection of underwater infrastructure? Is it an open question? Yes,
3 hours.
you
right?
are free for that.
Okay, well, thank you for the question. I'll try and scrape the surface of that. So we take it with an approach of swarms. So we specialize in swarms, and that's what we're bringing to the table. So we have a little bit of a different approach. We see the oceans, 71% of the planet, to explore, and the solutions that exist today are just a small way of seeing a small section of the oceans. What we're looking at, how we're approaching it, is we want a tool, and that's why we did swarms, to be able to take a lot of data in 3D, modelize 3D space in a different way. It's a different way, but it's a mass vector of data acquisition. So our first step was that. And when we had that vision, like I said, there's multiple steps to get towards how do we protect infrastructure underwater and how. But one of the first ones was the drone. What drone could we imagine? What kind of missions did the drone have to make? What kind of drone could we make to be able to answer the needs that we foresaw in the oceans? And it's very different. We have drones mostly, when you imagine Navy, it's kind of a torpedo-shaped drone, and like you said, they go forward, they don't stop, they don't hover. They're very, very wonderful tools, but they don't answer the needs of a swarm. So we make drones a little bit differently. We make drones that are more like helicopters. I like to compare airplanes and helicopters. Ours don't go fast. They don't have to, but they have to be precise in their positioning, because the key is collecting data and making sure we know where we're collecting the data from. So they hover, they have 4 engines so that we can control their altitude. So it's a different approach, first off. Then we also were like, well, we have small drones. We want small drones for logistical purposes. It's easier to put 200 small drones in the water than one big one. We want to reduce the cost. We want to reduce the equipment surrounding the need of using swarms. The goal is being that it could be easily used on multiple types of ships. So we want to reduce the size. But if we reduce the size, we reduce the batteries, so how can we optimize? We want them to stay a long time in the water. We're going to make heavy drones. So we're very unique, is we make drones that actually go and sit on the seabed. And they stay a long time, and they do their job, because they don't have to move, because they don't have to cover a big area, because they're covering a big area, because there's lots of them. So they're already covering a big area. So we're making them heavy. So we're changing a bit of that approach. So having the agility of being able to take the problem from a different point of view. We're trying to complete the data set. We're trying to complete the tools that are possible to be used underwater. So that's the first step. Using this agility to be able to conceive new operational models. And when we're talking now of protection of underwater structures, you understand that if you have small, heavy drones that can stay a long time underwater. All of a sudden you have what we call sentinels, underwater sentinels, little drones that are very hard to detect, that don't make any noise, that stay underwater for long periods of time, and that can collect all kinds of data depending on what kind of payload you equip them with. So that has been our approach. We've had a bit of a, but again, weirdly enough, we had this approach for the civil market, but today with what we see in the news, especially with underwater cables, data cables, other kinds of infrastructures that are going to become more and more strategic assets that we have to protect, we're seeing that this approach is actually quite pertinent and can have a nice future ahead of it.
Thank you, Tamara. I think it's time to open the floor to the audience. Don't worry if you haven't any questions.